Thank you. Thank you so much, Brian. So good evening, everyone, and welcome to this talk on scaling SQL at Flipkart with TiDB. So I'm Kaustav. I'm a senior architect at Flipkart in Flipkart's internal DBaaS team. Now, some of you may already be familiar with Flipkart, and you would know that Flipkart is India's largest e-commerce company. However, some of you may not be so familiar. So I will have some slides coming up later where I'll talk a little more about Flipkart. Now, these are the four main topics I plan to cover in this talk. In the first part, I'll give you a high-level overview of our journey with TiDB at Flipkart. I'll talk about what motivated us to look at TiDB, how we got started, and where we are today. Now, having looked at that, in part two, we will look at a specific service where we applied TiDB to get a little more details. Then in part three, I will summarize our overall experience having used TiDB. And in part four, I will briefly touch upon what we intend to do in the future. So with that, we'll get started with part one. Now to understand what motivated us to get started with TiDB and how we have been using it, it is important for me to give a little bit of context about Flipkart. So Flipkart is India's largest e-commerce company. And when we are talking about India, we are talking about a country with a population of about 1.4 billion people, of which about 700 million are estimated to be internet users. So naturally, as the e-commerce company in India, the largest e-commerce company in India, we are talking about massive scale. And you can see some of the numbers on the slide. So Flipkart has more than 400 million registered users, which is greater than the population of the United States of America. At that scale, we are talking about greater than 10 million daily page visits and more than 8 million shipments per month. And Flipkart is organized as a marketplace. So different sellers can come on board and sell their products. And we have more than 100,000 sellers. And to deliver the goods to our customers, we have more than 22 warehouses distributed at different places over India. Now, to further give you a sense of the scale, we have a major festive season sale that happens annually around September, October. And we just wrapped up the sale for 2022. It was an 8-day event, and it registered more than 1 billion visits. And the overall GMV from that sale in this 8-day period runs into multiple billions of dollars. Now, if you are interested in knowing more about that, here is an article that is available that I've linked in the slide below. Now, definitely, as you can imagine, there is a lot of tech behind all of this. So when we are talking about Flipkart, we are talking about the entire range of the e-commerce operations. That includes the front end, the website, app. Then definitely there is a catalog, there is inventory, there is search, payments, order, shipments, logistics. Those are all the obvious ones that come to mind when we think about an e-commerce company. But there is a lot more than this. And these functions really are business units within Flipkart's. And these have teams and sub-teams, and then they own multiple microservices which deliver these functions. So net, we are talking about thousands of microservices, stateless and stateful. All of this runs out of 3 data centers, 2 of which are on-prem owned by Flipkart, and we use one public cloud. We have our internal Flipkart cloud layer to help us with all of this. And at the IaaS layer, we are currently running out of a mix of VMs and containers, but internally we are moving entirely to containers. Now, as you can imagine, all of these functions and thousands of microservices being there will be a lot of common problem statements that these teams need to solve for. So it is not enough for us to just have VMs and containers. We also need a lot of managed services. And for that, we have a rich ecosystem of managed services internally in Flipkart. Things like security and identity management, messaging services, big data analytics platform, And a lot of the databases are provided as a managed service, as a DBaaS offering internally within Flipkart. Now, on that, let's talk specifically about the kind of data we deal with at Flipkart. So if you think about the different functions that were mentioned, let's say payments, orders, logistics, you'll see that a lot of them deal with data in one form or the other. So the thousands of microservices that I spoke about, a lot of them are stateful. And these different functions, they access the data, they have different access pattern requirements. So there is large variety of, or the requirements of the application are quite varied. So we end up using quite a few different data stores. We have MySQL, we have Redis, Aerospike, Elasticsearch, Edgebase, Mongo. Those are just to name the top few. And apart from a variety of the data stores, if you can imagine the scale that I mentioned, we are dealing with a large quantity of data in these data stores. The hot transactional footprint itself, we estimate to be about 2 petabytes. But when you put together the big data, ML, other archival systems and stuff like that, it is a lot more. And in the hot transactional space, MySQL is the most commonly used data store. About 70% of the instances are MySQL. And we also have a MySQL as a DBaaS offering within Flipkart. And this DBaaS offering handles about more than 600 clusters, which are spread over more than 1,800 VMs. And that footprint itself is 1.5 petabytes. And of course, with the growth in business, this data volume is growing, the throughputs are growing. Now, there are some top concerns that are always top of our mind, and this has been the case for several years. This is not new. And I'm sure many of you will be able to relate to this based on your own experiences. So scalability, reliability, efficiency, these are very important concerns. When we have a huge scale in business and very rapid growth in business, that directly translates to a huge scale of data and rapid growth of data and the throughputs of access to that data. So when we start hitting the scalability limits on our traditional transactional data stores, we have to ask what are our options, right? And what kind of architectures do we opt for in our data stores? Not just to handle the data that we have currently, but also we need to make sure that those systems will be able to handle the future growth, at least 3 years, 5 years, maybe some time frame like that. Then there is reliability. I just spoke about the annual festive season sales, few days of sale, doing multiple billions of dollars in GMV. Now you can imagine if a critical service goes down, stays down for several minutes, that amounts to huge losses. So we need our applications to be highly available, but for a stateful application to be highly available, that almost directly translates to the database being highly available, being able to tolerate all kinds of failures of individual nodes, rack, or maybe even a regional level failure. Then there is efficiency. Now, just because of the sheer number of data stores or database clusters that we are running, every little bit of efficiency counts. The obvious part of efficiency is that if we are running on the right number of machines, the right number of cores, that's one aspect, right? The day-to-day maintenance of the data stores, the provisioning of the data store, how quickly we can recover from day-to-day failures, all of that matters. If those are complex, if those are costly, then all of that gets multiplied by the sheer number of data stores that we are running. And that adds up to a huge cost in total. And there is another subtle aspect to this, right? It is not just the machines that it is running on, not just the maintenance that we need to do, but is the data itself easy to work with? Does the database provide it in a form that it is easy to work with in terms of a data model, having transactionality, having consistency? While they come at a cost, they also make it easy for applications to reason about the data, they simplify the applications. And the cost of application complexity, right? If the database makes the application complex, then that again has a cost, and that again gets multiplied by the sheer number of data stores and microservices that we have. So on that aspect also, it is important to have efficiency. Now, it is with these kind of concerns and these kind of thoughts that about in 2020, we started to see this distributed SQL technology coming up, and it started to look really interesting. And why is that? As I mentioned, we already have a very wide base of MySQL, or if you say traditional SQL data stores. And they are great, right? Because they are battle tested. They have been in the field for decades. They have a rich ecosystem of tools. There is a great community around them. There is great knowledge available around them. But we are starting to hit those fundamental architectural limits of those stores, right? They are vertically scaled. They have a single point of failure, and these are starting to become problem points because of the scale at which we are doing business. Now, in this space itself, there has been extensions built on MySQL. The notable ones, Galera, group replication, Vitess, we have tried out, and we do use some of them in Flipkart. Now, if you look at Galera or group replication, they solve for the HA problem, but these do not solve for the scalability because they do not shard the data. These are still vertically scaled. On the other hand, you have Vitess, which is a great solution for managing a sharded MySQL cluster. But in terms of HA, it is really providing what vanilla MySQL provides. Now, this is where when we were looking at distributed SQL databases, the good thing is that it offers those great SQL features, the SQL data model, the transactionality, the consistency. Then it is solving for high availability, it is solving for horizontal scalability, and all of these are coming together as one package. Now, we don't have to pick one versus the other, right? But at that time, right, this emerging technology, there was a decent amount of skepticism around it. So will it really scale? Because as we saw from the architecture, these are sharded, these shards used consensus, Raft or otherwise, and then they support multi-shard transactions. So when you get into that territory, people really begin to get concerned, can this really scale? Can this really deliver the performance? Then though we are talking about data being replicated using consensus, does the HA guarantees really hold up? Is there some fine print to it? And overall, will these databases be stable enough for production use for us to put it into use in a company which is running at the scale of Flipkart? So these were the concerns at that point in time, but the technology was looking very interesting. So the best thing we could do at that time was get into an evaluation and see if the promises really hold up. So with that, we got into, we did an evaluation of the available distributed SQL databases. We looked at quite a few aspects. The evaluation was quite detailed in many ways. Obviously, we had to look at the SQL features themselves because SQL on its own is a huge surface area in terms of features. There is not only the SQL data model and the various data types, the various functions that are offered. There are secondary indexes. You have to think about joins. Then there is the whole transactionality bit of it, the various isolation levels and things like that. So we looked at all of those aspects, what is provided by each of the options. Then definitely the scalability part of it, because that is the problem we were trying to solve, is that can we add capacity and can we incrementally scale the database? How much of effort will that be, and does that promise really hold up? Then there is the failure tolerance aspect of it. That impacts the DB in two ways, right? When things fail, do we still have the data durability? Do we lose data? Does the DB stay available? Can it continue to process transactions? And with all of that, the question is, if the DB is still providing all of that, can it do it with great performance? So for us, these top four things, this was the core of the database. It was important to have all of these. But then again, to put it into production in a real life enterprise situation, it is not enough to just have the core database. There are a lot of additional functionality that you need surrounding the database. We needed good backup support, not just full backup, but incremental backup. Because now, if you think about it, multiple TB data sets, and if we are frequently backing up and we are backing up the entire data set frequently, that adds up to a huge amount. And being able to do incremental backup matters a lot. Then we are looking at security features, security at rest, security in motion. CDC is very commonly used in a microservices world to propagate changes. Replication is required to be able to set up active passive clusters and be able to fail over in case of regional disasters. And then, as I mentioned, we provide these databases mainly as managed services. And if our team cannot get an idea as to what is happening in the database, if it is performing well or not performing well, uh, we need that observability. That is very important for us. And then in Flipkart, we are moving heavily into Kubernetes, and therefore K8s support mattered to us a lot. So these are all the aspects that we considered, and these are the options that we looked at. We looked at TiDB, Yugabyte, CockroachDB. Definitely, all of these are very well-known databases, very well-known distributed SQL databases. Each of them had their strengths and weaknesses, but overall for us, TiDB emerged as the best fit and the winner of this evaluation. And there were quite a few things that worked really well for TiDB. The scalability, the failure tolerance, those promises really did hold up. But then it also had these other features available at that time in 2020 itself. The backup features were there with incremental backup. It already had the security features in place. TiDB has great observability. For those of you who have looked at the Grafana dashboards, you would know they're pretty rich. And in that time itself, TiDB had a mature, already GA K8s operator, which was a great fit for us. So based on all of this, we decided to go ahead with TiDB. This was in late 2020 that we did this evaluation. We concluded the evaluation, and we took some time to look at TiDB in a little more detail, and then we put our first use case into production in Q1 of 2021. That was the first use case. Then we went on and put a few more use cases into production. And at that time, parallelly, we were also starting to have talks with PingCAP. And we decided to go for the enterprise license in late 2021. And since then, we have been an enterprise customer of PingCAP using TiDB enterprise version. So from there, this is where we are today. As of October 2022, we have 15 use cases in production. Overall total storage footprint across these is more than 90 TB. Some of the clusters are a little bit on the larger side, like the largest cluster has 40 plus pods and about more than 30 TB of provisioned storage. So that hopefully gives you a high-level picture of what motivated us to look at TiDB and how we got started and a summary of where we are today. Now, with that, let me zoom into one particular service where we applied TiDB and look at some more details around that. Excuse me. So the particular application that I'll be talking about is a coin manager application, what we call coin manager. And the coins that we are talking about really are super coins, which are the loyalty points that customers earn on Flipkart. And it is not just for Flipkart. These super coins can actually be earned and spent on other partner e-commerce systems, which are also very large e-commerce properties in India, Myntra, ClearTrip. And this coin manager service essentially manages the Supercoin virtual currency. Every customer has a wallet where when they do activities that earn coins, these coins get credited. And then when they are making payments, they can choose to pay with Supercoins. So this particular coin manager service acts as that payment processor as well for Supercoins. So as you can imagine, this is a business critical application. Why? Because it has a very high customer visibility. Firstly, customers care a lot about their loyalty points when they're earning those points. That data is important. The integrity, durability of that data is important. And the customers, once they have earned points, they would like to spend it as and when they want. If they are not able to do that, that translates to really bad customer experience. So the availability of this service matters. And this service is coming in the payment path of not only a very large e-commerce property like Flipkart, but multiple others, Myntra, ClearTrip. So if this service has a problem, it's not available, multiple e-commerce properties, big e-commerce properties get affected. So what are the kind of requirements that this application had? The team was looking, definitely highly desirable was a SQL data model with asset properties. Um, when we are talking about an application like this, which is managing a virtual currency, you'll imagine that it's like an accounting model which has a ledger where the credits and debits are being noted. There is a wallet with a current balance, and whenever coins are credited or debited, there are additional data around it that you want to update to maintain the traceability of those credits and debits. So there are multiple values that you want to update for any operation, and you would want to update those transactionally in a consistent way. Modeling all of this into a NoSQL kind of data model may be possible, but it is hard. Now, high availability, of course, is another very important requirement for the reasons I already mentioned. At the high scale of Flipkart, having a database running across multiple nodes, day-to-day failures of nodes are expected, and the database cannot be unavailable or cannot lose data because of that. And not only do we have to guard against the day-to-day node failures, but we also want to provide for the possibility of catastrophic failures where the entire region has a failure. Then we would want to be able to quickly run out of another region. So having active passive ability is very important. And when we started considering this application, it already had a lot of data. We were talking about 3 TB of data unreplicated. And it was also having a very high growth rate, up to 300 GBs per month. And from that rate, you can see that in a year, we are going to almost double the data footprint. So therefore, whatever storage option we choose for this, it has to be horizontally scalable. And we are definitely looking at scaling it in a very short period of time again, right? And the throughput requirements at that time were around 12.5K writes per second, 5K reads per second. The reads were a little lower because we had a cache around it as well. So the read on the source of truth database was a little lower. And the desirable latency numbers for the application were around less than 100 milliseconds for writes and less than 20 milliseconds for reads. These are P99 numbers. So with those requirements, what was the data setup for the application? And this was prior to us applying TiDB to this. So there were two regions. On the left, we have the region 1, which is active, region 2, passive on the right side. We have the coin manager application running on both regions. The active region serves both reads and writes. The passive region was serving reads. It was not just sitting idle, it was serving reads at that point in time. And to be able to handle the 3 TB scale of data and to be able to grow the DB later on, the team opted for a sharded MySQL setup. They used a 5-way consistent hashing way to go about it. And this hashing logic was implemented in the application itself. Now, below you can see the database organization. And as you can see, it is already very complex from the diagram. So there are 5 shards. Each of those 5 shards has a master, a hot standby, and a read replica. This is on the active side. And then to be able to fail over to the passive side, each of those shards has a hot standby on the passive side. And then the passive side is also serving read. So for that, we have a read replica on the passive side. So each of these 5 shards, we have 5 database nodes per shard, leading to a total of 25 DB nodes. Between the nodes, we are looking at 20 replication channels. Now, you can imagine what it takes to maintain a cluster like this on a day-to-day basis, because any of these nodes can fail and the replication channels can have problems. To make sure that the coin manager application is healthy and running fine, each of these 25 DB nodes, the 20 replication channels needs to be in good health. So the team is continuously busy making sure that each of these components are in healthy state. But apart from day-to-day maintenance. Think about a disaster scenario where we have to switch over from region 1 to region 2 that requires coordinated failover of 5 shards. And then because of the high growth rate, we are looking at an inevitable addition of more shards somewhere down the line. And there is no option but to reshard the data, which is also going to be painful at multiple TB scale. So this is what the application looked like in 2020. And then we started to, this is the application we considered as one of the prime candidates to move to TiDB, which is what we did in the early 2021. And at the present day, this is what this application looks like. It is greatly simplified. As you can see, it is still running out of 2 regions, active and passive. The Coin Manager app still continues to run in both places. Active side serving reads and writes as before, and the passive side serving reads. But the underlying structure of how we have deployed the database has changed completely. We have basically 2 TiDB clusters, one on the active side and one on the passive side. You can see the configuration of that TiDB cluster, 3 PD nodes, 10 TiDB nodes, about 33 TiKV nodes, and 11 TiFlash nodes, identical on the passive side. And these clusters are now not running on individual VMs. They are hosted in a Kubernetes cluster. So all of this is running on Kubernetes, and we are making use of the TiDB operator on Kubernetes. So it is not just that the diagram is simplified because we are just drawing a box around one box and calling it a TiDB cluster, whereas internally, if you see, it has 50 pods on each side, right? Total of 100 pods compared to the 25 before. But it really is one box now because the combination of TiDB and Kubernetes means we are dealing with stateful sets, particular pods going down, they recover mostly automatically. TiDB operator takes care of reacting to a lot of day-to-day incidents. And therefore, we are no longer really maintaining 25 individual nodes as we were doing before. So this is what it looked like with the Coin Manager application. As I mentioned, there are total of 15 use cases that we have put into production till date. The story for the other 14 were quite similar mostly. Many of them were either already running on a complex sharded MySQL setup like this, or they were hitting the scalability limits and they were trying to figure out what to do. And they largely had the option of deploying something like this, or they had to kind of remodel their application to work with a horizontally scalable NoSQL database. So at that point, many of these applications, we decided to move to TiDB. So what were the benefits of doing this specifically for the Coin Manager application? And if I consider the rest of the 14 applications, so that is what I will summarize in this third section of my talk. I will talk about not only the pros and cons of doing this with the Coin Manager, but I'll generalize a little bit and include the experience with the other applications as well. So these were the benefits that we have gotten from these activities. The number one benefit has been a simpler application, and it is simpler in 2 ways, right? The application has been able to retain their SQL data model and asset guarantees. It is not always easy to move away from this and model your data and application around a NoSQL kind of data model, which does not provide transactional guarantees. On that aspect, it is simpler. It is simpler on the other aspect that also the application no longer has to implement any kind of sharding logic, right? So all of that is removed from the application, and it is simply talking to one database. And the management of the database, of course, becomes simpler. We are no longer managing those 5 shards, 25 nodes, 20 replication channels, but we are just managing 2 TiDB clusters and 1 replication channel across these clusters. And in that also, the combination of Kubernetes and the TiDB operator has worked really well for Flipkart in practice. The no single point of failure promise really does hold up. Having running these clusters more than a year in production, we have had ample number of incidents where nodes, pods died, and the cluster was still able to continue running, both in terms of having data durability and also in terms of not suffering from in terms of availability and being online. There are also incidents where we had to execute a failover. They also went fine, and it was, of course, simpler failing over one cluster to another. And we have also done a fair bit of horizontal scaling in production. We have scaled up some of these clusters. We have scaled down some of these clusters. And we did all of this while they were running in production, serving production traffic. And so far, all this has worked really fine for us. The other aspect that has also worked well is the MySQL compatibility. So when we have put these 15 use cases into production, they were already using MySQL. And for some of these applications, they didn't have to make any changes at all, right, to move from MySQL to TiDB. But of course, there are differences between these two databases. And in some cases, some changes were required, but they were largely not too intrusive. Now, these are great benefits, but I also don't want to give the false impression that everything was rosy all along the way. We did face some challenges. When we got started with TiDB, we started with the 4.x version in early 2021. At that time, when we started to use it for the coin manager application, the latencies were on the higher side.
Hey, Kaustav?
And it was concerning. We reached out to the community, to PingCAP, and fortunately
Hey,
at that
Kaustav?
time, 5.2. Yes,
Yep.
Brian.
Sorry. I need to ask you to pause real quick. We have a question on the floor.
Sure.
Sorry, it wasn't a question. It's just your slides are not presenting. Can you try to, or your slides aren't advancing. Can you try to advance the slide
Yes.
again? There we go. Thank you.
Okay.
Were you able to see the benefit slide that I spoke about?
Yes.
Okay, great. So, so this is the challenges part, right? Now I can see that it is showing on the screen. Yep. So as I was mentioning, yes, TiDB 5.0 came out, and one of the big improvements in TiDB 5.0 was the clustered indexes that came in at that point in time. It definitely made the latency a lot better and a lot more stable. There was the jitter in the latency also went down. And with that, we were able to move ahead with moving the coin manager application onto TiDB. Now, of course, in newer versions, 5.4, we have tried out and we are seeing much better performance with that as well. So I think that's really great to see the performance getting better version over version. The second point about higher latencies. Now, what I mean here is that it is natural for applications to start comparing when they're moving from MySQL to TiDB to do a comparison between absolute latencies that they can achieve on MySQL and with TiDB. Not wrong for them to do that, because at the end of the day, these applications have SLAs and there are certain latency bounds that they're trying to adhere to. But at the same time, we understand traditional MySQL, TiDB, these are fundamentally different architectures, and the guarantees that TiDB brings to the table in terms of surviving failures with zero data loss, maintaining availability, all of that, the robust way of doing that is through consensus. And when consensus is involved, there is some latency penalty to be paid. So at Flipkart, the way we are looking at it is that this is really a trade-off that we have to decide on. If we can pay a few more milliseconds of latency to get these great benefits, that's something that the application has to consider. In some cases, it is possible that they may not be able to absorb that additional latency, and that's a call that the application will have to make. Now, there are a couple of more challenges that we faced in the area of replication, particularly transaction atomicity. Now, TiCDC very clearly calls out in its documentation and in practice as well that it does not guarantee the atomicity of multi-table transactions. Now, I spoke to you about the coin manager application, and you can imagine how a wallet service like that would be modeled in SQL, right? And it definitely needs multi-table transactions. And then we are running it in an active passive mode. And the expectation from the application is that, I mean, we understand it is async replication. So definitely data on passive side will be stale, but it needs to be logically consistent. We cannot violate the invariance of, having different tables, having different data from different points in time. And this was the state, though, in 2021 when we onboarded the Coin Manager application. And this was a big problem for us. It materializes in two ways, right? If we fail over from the active side to the passive side, there is no guarantee then that the data on the passive side is transactionally consistent and the logical invariants hold. And also, as you saw, the passive side was serving reads. So if those reads refer to multiple tables in any case, then the read could potentially serve inconsistent data. So these were very big concerns. We discussed this with PingCAP, and fortunately, they were very receptive. They understood where we were coming from and why it was important for these kind of applications to have that kind of transactional guarantees even across the replication channel. And for that, PingCAP went ahead and implemented two features in TiCDC. One is eventual consistency, and the other is TS map. With these, we are able to fail over and from a logically consistent point. And also the TS map feature allows us to do reads which are logically consistent. So with that, this was a big challenge, and we were living with this limitation for several months. But fortunately, now this has come to closure, and these two problems are gone. The other issue that we faced were replication bugs. In one case, we found that some records were not getting replicated. This was found by the application team. PingCAP investigated for us, and it was found to be a bug, which was then subsequently fixed. There was another incident where we were not impacted, but there was another bug that was discovered by another customer of PingCAP. When this was discovered, and PingCAP found that there is a bug, and they developed a fix for it. This problem was known to Flipkart, and PingCAP proactively provided the fix to us. While these kind of replication bugs are very concerning, right, because of the kind of data and the scale that we are dealing with, it's very hard to even know that some records are getting missed in replication. So these are definitely concerning, but on the other hand, it's great to see this area of TiDB getting attention from the community. I know there is work going on in replication to make it better. And what was really reassuring for us is the transparency and proactivity that the PingCAP team had around this to let us know that there was a bug like this, and letting us have the fix for it in advance. Now, so far, I have not talked about HTAP. But in Flipkart, we have not really fully leveraged the HTAP capabilities of TiDB. We are largely, in our journey so far, we have been focusing on the OLTP aspect of TiDB. In all the use cases where we have deployed it, we have been focusing on how to replace the OLTP functions of the traditional SQL with TiDB. We do deploy TiFlash. You would have seen that in the diagram that I shared for the Coin Manager application. But we are using it largely simply at this point of time. We use it to take some timeline consistent dumps, which are used. These dumps then support some of the ETL and archival processes. And definitely, we do not want those dumps to affect the performance of the TiKV nodes, and therefore we use TiFlash. But this does not, in my opinion, leverage the full potential of what TiDB's HTAP is capable of. And that is an area, I think, where we will do something in the upcoming future. And on that note, let me quickly get into the last part of the presentation, which is about what we intend to do with TiDB in the future. Now, there are quite a few things that we are interested in, but these are kind of what is top of mind. One is starting to apply TiDB to much higher throughput applications. Right now, the kind of applications that we are using TiDB for runs into maybe 10, 20K throughput. But there are some applications in Flipkart which are very high throughput, like 100K or more. And Now we want to see if, given that TiDB is horizontally scalable, this looks like the right technology to start applying to very high throughput applications and apply horizontal scalability to tackle this problem. So that's one area where we are going to do some work coming up. And the other aspect is, as I mentioned, Flipkart is running out of multiple regions. We are already running out of 3 regions. And given our business requirements, our business continuity requirements, we would like to run some of these applications in an active-active configuration. Now, when the application is running active-active, what is the right topology or the right way to use the database? How do we deploy and run TiDB in such a case? Those are some of the discussions we are having right now with PingCAP, and we are looking for those kind of solutions. And lastly, as I mentioned, the HTAP is an important part that we have not yet looked into. Flipkart has a very capable internal big data analytics platform, so that is used for the bulk of the analytics. But there are definitely use cases where to support business operations, we would like to be able to do quick OLAP queries on the OLTP data in real time. And we think HTAP will be a good fit there, but that is where we need to explore and figure out exactly how we put it to use. So with that, that is the end of my talk. And I would be happy to take questions if there are any.
All right. All right, any questions from the room? We've got one coming up.
Hi, yeah, thanks for the great talk. One question I had was actually something that was touched on by a previous presenter, where they mentioned that when using TiCDC, they sometimes saw like long replication lags when running a heavy write operation at the same time. Have you seen any kind of similar performance replication lag issues with TiCDC? And I'm also curious to know what your RPO and RTO are for your cross-regional failure operations.
Yes, thank you. So we have faced some of that with our coin manager application. So what happens is that we benchmark and we provision the enough capacity for the day-to-day needs of that application, even the peaks of traffic that it expects. And what we have seen is once we have provided adequate number of TiCDC nodes, at least the traffic that is there on a day-to-day basis, the peaks and valleys that we have on that, we generally do not face heavy lag on TiCDC. But this application also runs some nightly jobs where there is expiry of coins, there is archival of data. And these, like for example, if we archive, we delete a lot of records from the main data store on TiDB. And when these bulk operations run, we do see an increase in the lag in TiCDC. Now, the kind of RTO, RPO we are looking at is of the order of, RPO at least is of the order of minutes. We would not want to lose more data than, let's say, 5 to 10 minutes. But in terms of RTO, we do have, I mean, in the extreme case of a regional failure, we are okay to have a few hours of failure time. But it is desirable, again, to have that pretty low. In the extreme case, yes, I think a few hours is acceptable there. I hope that answered the question.
Yeah.
Yes, thank you.
Any other questions? No? Going once? Going twice? I think the audience here, Kaustav, is a little bit wary. You brought us home and closed the event for us, so thank you very much for getting up so early your time to share your story with us. It was an amazing story.
It was my pleasure, and thank you so much for the opportunity to let me share this journey with such a wonderful audience. Thank you so much.
Absolutely. And we will let you move on with your day, or maybe even catch a little more shut-eye, whichever is on your agenda. And thank you again, sir.
Thank you. Have a great rest of the day.